This is the video for FIF4, Unit 4, on quartic functions, quartic key features. And you might recognize that FIF4 comes from a lot of units. There's FIF4 in Unit 2, which talked about quadratics, so basic parabolas. Unit 3 had FIF4 and it talked about cubic functions, and now Unit 4 is about quartic functions. And you might be saying, quartic, what in the world is that? That basically means the highest power in the polynomial is a 4. So it's to the power of 4, or quarters, like 4 quarters in a dollar, quartic. All right, so these are the two types of graphs. They will be a W that either points up or a W that points down. And it may not be a super curvy W, like this part right here may not be as curvy as this. It might be just like barely curvy, but this is the general idea of what happens with quartic functions. In general, there's something that you should know, and I don't know when you'll go over it, so we're just going to skip over that. Okay, so these are the key features. I went through and I listed all of them that you will need for this thing, and there are 2 in here at the bottom that are newer, something that we haven't talked about with the other FIF stuff that we've done. So hopefully it'll make sense to you. So domain, it talks about the x's, and we're going to talk about it from left to right. Well, so basically it's if you were to take compact this graph all the way down flat. So instead of being a W as a flat line, it would basically be pointing in both directions like that, right? And that means that the domain goes from, there's 2 ways of writing it. You could say from negative infinity to infinity, or another way of writing it is a double line R that stands for all real numbers. So anything, we can put in anything for X and we'll get out a Y. The range goes from the bottom to the top, or you describe it from the bottom to the top. So I'm going to change color even. As we're going from the bottom to the top, with this one, the smallest Y value, because it's the Y's, I'm going to put a Y right there so it kind of looks like a Y with that. As you're looking at the bottom of those, or if you're looking at the top of these, then that's the maximum or the minimum, and you're going to talk about from the bottom to the top. So the smallest number in terms of Y on this one is going to start at 0. So a bracket like this means it includes 0, and then it's going to be, so that basically if you smashed it the other way, it'd start right there and go up. So it'd start at 0 and go to infinity for this one. And if we did it for this graph, it would start at negative infinity, and it would end at, I don't know what number that was, 1, 2, we'll just say it was 3. Okay. Then the end behavior talks about, does it go all the way up? Like as you look to the left, because this part right here, this is a fancy way of saying as you look to the left, is it going to go up or down? So as I look all the way to the left, let's see if I can just delete that thing and just delete that thing. Yeah, good. As I'm looking to the left, let me change it to orange. If I look to the left, is the graph going up or down? Well, it's going up, and so that means it's going to go to positive infinity for this one. And then same thing, if you look to the right, it's also going up forever. So it's also going to positive infinity. While on the other hand, with the one on the right, of the function on the right, we would have to say as x goes to the left, so negative infinity, f of x goes to negative infinity because it's pointing down. This is saying down. And then as x goes to the right, f of x goes up. Also goes down, sorry, negative infinity. So when you're dealing with any of these polynomials that have an even number, the highest exponent is an even number, so 2 is for quadratics, and that's a parabola. Or if it's 4, which is a quartic, or if it's 6 or 8 or any of those things, they're going to be pointing in the same direction. So the end behavior will be going to the same end behavior. All right. Any questions on that so far? Next thing is the zeros. So the zeros are basically describing the same thing, but zeros and intercepts are describing the same thing, but they have a different format. So on this one, let's change the color to yellow. For the zeros, it would be x equals a number. So here's our x right there, and there's our x right there. So the zeros, oh, I can't write it in that color because you can't see it. Let's write it a darker zero. And put the zeros would be at x for this one, would be x. Maybe this is -2, and that's +2. So x equals -2, and x equals 2. X equals -2, and x equals 2 are zeros. But then the y-x-intercept for that is very similar. It's going to be, the x-intercept is -2, 0. And then for this one, it'd be 2, 0. And then for the one on the right, let's do, so it crosses 3 times on this one. Right there, there, and there. And technically, if we were to, let me just show you on this graph that we have on the left or on this one, if we were to move it down a little bit, if we were to say instead this shape was like that, notice technically you could have 4 different places that it crosses. Cool, huh? But I don't want that on there. Okay. We're just going to say those 3 places. So let's say maybe that, if that is 1, then that's back 1, 2, 3, 4, and then +4. So for this one, I'll just go like this so you can kind of see it goes with that one. We would have a 1, 0 at x equals -4, x 0, and 4. Or the x-intercepts would be -4, 0, 0, 0, and 4, 0. So you're just talking about where it crosses the x-axis. Y-intercept is where it crosses the y-axis. So if we did this color, crosses right there, crosses right there. The x-intercept goes 0, number. And these would be, maybe this would be up 3 on that one. So it'd be 0, 3 for this one. And then for the one on the right, it'd be 0, 0. So notice that the x-intercept and the y-intercept are the same, and that this looks like a face. You could like make it have teeth. Okay. All right. So those are things we've done with with the cubic one, with the quadratic one. These are all the same. The cool thing, I think it's cool with these, is when you have a max and or a min, that there are usually 2 of one and 1 of the other. Like that has a little bit of everything. So this first one, we have a max right here, a local max right there, local. And then we have a minimum right there and right there. And then this would be a min, and these would be local maxes. Max, max. Okay. So then you just say what those points are. So the max would be on the left one, with the maximum would be at 0, 3. And the minimum would be at those points, which is at -2, 0, and 2, 0. And then for this one, this has 2 maxes and 1 min, and the max would be at, looks like that's at back 2, up 3. So max at back 2, up 3. A minimum, local minimum at 0, 0. And then the other one is going to be at, my graph is weird, but it's going to be at 3, 3. Okay. I like these. I like that there's 2. Any questions on what we've done thus far? Okay, we'll keep on going. We've also talked about increasing and decreasing. So increasing means as you're going from left to right, it goes up. And decreasing means as you go from left to right, it goes down. So we talked about in other lessons a skier. If you imagine a little skier on the slope, like starting on the left side, if I put a skier right here, this is my skier, there's one leg, there's the other, there's the skis. They would go down, right? So that's decreasing. So let's mark these as decreasing. So this is decreasing to there and decreasing to there. Notice there are two places where it decreases. And this one again decreases right there and decreases right there. So two places where it decreases. And similarly, there will be two places where it increases. So it's increasing there and increasing there. Because as I go from left to right, it goes up. Increasing and decreasing. So and then we talk about it in terms of intervals. So let's see, increasing on this first one, that's the green ones. So it starts at -2 on the x-axis and goes to, so increasing, I'm going to put x-axis. So it's increasing from -2 to 0. So I'm looking on the x-axis, it increased from here to there, and then the x is on those. That was -2, and that's 0. And then it starts again at 2 and then goes to infinity. So then it starts 2 to infinity. And then decreasing would be from -infinity to -2, basically everything else. So -infinity to -2 and 0 to 2. So when you're looking at increasing and decreasing, you need to talk about the whole graph. Let's do the other one. This one, so we had increasing is the green. So that's going from -infinity up to that number, which is -2. So it's going to be from -infinity to -2. And then again from 0 to 3. And from 0 to 3. And then decreasing is the rest of it. So if I want to look, I can, or I can just say I know that between -2 and 0, it's decreasing. And then from 3 to infinity. Let's just make sure that makes sense. So from -2 to 0, and then from 3 to infinity. Okay, this is the last thing and the newest thing, and then basically this is the end of the lesson, and we'll just do some examples from there. So this is positive and negative, and positive, negative is also going to be spoken of in terms of intervals, but it's talking about where it's above the x-axis and below. So notice this entire function, this entire function is above, it'll show me, it's above the x-axis, right? But it's only positive on this one at that little, like at this part right here. That's the only places where it's above the x-axis. And it's below the x-axis from here down and from there down. So this is positive, and I'll put in parentheses, above the x-axis. And this one is below x-axis. Okay, so let's talk about it with those intervals. So this one, basically, it's always going to be above, although it could be argued that at where it crosses the x-axis, where it touches the x-axis, that it's neither, but we're just going to say it's all above. So it's going to be from -infinity to infinity for this one. For the one on the left. And then for the one on the right, and there's nothing negative, so I'm going to put none right here. And then for the one on the right, it's going to be positive between -4 and +4. I mean, positive between -4 to 4. And then negative from -infinity, because that's all the way left, to -4. And 4 to infinity. All right, that's basically all you need to do for the whole thing. So it's just doing the FIF4 stuff again. And if you miss that with other ones, then that's it. So that's the main lesson part. Now I will just do examples. So let me get a good example for this. Oh, where did it go? That's funny. I thought I had it up. It disappeared. I'm going to have to pull it back up again. So hold on. Any questions on what I talked about? Woman of many words. Okay, so let's go to assignments. And then I'm going to look at the actual quiz just so I can get some problems that are similar to that. Examples. So I'm not going to do the exact problem to the quiz, but I'm going to do one very similar to it. And this relates to the workbooks that you're currently working on, but that's where we're at right now. So almost there. The questions here. Okay. All right. So it's going to ask, it'll give the first one. I'm just going to tell you, it gives a graph, and then you have to answer questions about the zeros, the domain and range, the intercepts, the x-intercepts, like things like that. So let me give an example. Let's do one from Desmos. And I'm going to show you how these look. So if I were to go into Desmos like this, and then this might be one that they would come up with. So let's do, it would be x minus 3 to the power of 2 multiplied by x plus 3 power of 2, like that. So this one went really big as far as the W goes. Whoa, huge. And then it'll ask questions about that. So let's talk about the zeros. So if this was really my graph, I can literally graph it and type there's a 0, there's a 0. So we would say our zeros are x equals -3 and x equals +3. The domain for all of these would be from -infinity to positive infinity because it's arrows at both ends. And then let's see. I don't know if there's anything. All right. Yeah. So that's basically all I need for that one. I'm just making sure that that made sense. All right. Next one. Oh, next question on this. What is there? Are there 2 minimums or 2 maximums? Oh, that's such a weird graph. Let me see if I can like. Whoa. Okay. No, that did not. It doesn't like me. I'm trying to fight. Okay. Okay. Are there 2 maximum or 2 maxima or 2 minima? 2 maxima or 2 minima? Yeah, 2 minima. Perfect. And then it'll ask what those points are, and all you have to do is type. I mean, like click on the thing if you graphed it, and then that's what it is. And then the maxima would be that one. And then next question would be, what is an interval? And then these points where the maxima and minima are will help us. What is one interval where it increases? Where is one interval where this graph increases? It goes up from left to right. So it starts at 3 and then goes to where? So the interval, you would start by writing parentheses. You start by parentheses 3, and then where is it going to keep on? Like 3 to where increases? Yeah, good, perfect. So it would look like this, 3 to infinity, like that. Good. And then another one where it increases would be from -3 to 0. Again, we're talking about this in terms of the x-axis, right? So from this -3 to 0. And then decreasing would be the same type of thing. And then what is the end behavior? Let me put it this way. So as x goes to negative infinity, where does f of x go to? X goes to what? So if we're looking at the left side, where is it going to go to? Is it going to go all the way up or all the way down? So see how this is pointing. So as we look on the left side, it's only going up and literally nothing is pointing down. Like if I zoomed out forever, like up on this side, it's going up only. If I zoomed out forever, you could see it's only going up. So that's where it would go to positive infinity. So the negative infinity on that means the left side. Does the left side, if you were to go out all the way left, does it go up or down? Well, the graph only goes up, so it would be positive infinity. So you would say f of x goes to positive infinity. And then, no, you're not done. And then as you go to the right, it would be the same thing, right? Because both sides go up. So then you would say as x goes to positive infinity, f of x goes to, approaches is what they say, approaches also positive infinity. Wow, I can't type infinity. I'm Englishing so nicely today. All right. Trying to look if there's anything else that you haven't gone over. Okay, and then basically then they can change this thing up. So if we change that to a -1 instead right there, and maybe to the +5 right here, then you're going to get a different graph. And maybe there was a negative in front. Let's put a negative in front. And then maybe we'll make it even more differenter. And maybe we'll do like an x -2 right here. And then we'll do a x +3 right there. Whoa, that doesn't need that thing right there. So if I did that, notice how this totally makes the graph weird. So it's still a W, but it makes one side go woo, like way up. But the questions would still be having the same answers. So this would still be a minimum. That would be a local max, but so would this one up here be a local max. It would also be the overall maximum. So basically it's the same types of things. Y-intercept, you click on the y-axis and see where it crosses. And I think we've got everything. So that's FIF 4 for Unit 4.